any molecule easily مركب بطريقة سهلة while being sure about it. First, try this way. We are going to take C2H4 and the first step is to write the theoretical number or الرقم النظري, which is the perfect number of electrons an atom have. The rule is if we have any hydrogen atom in the molecule, we are going to multiply it by 2, and in any atom we are going to multiply it by 8. So let's try it on this molecule. We have 4 hydrogens here, so we are going to say 4 multiply 2, and then we'll add, we have 2 atoms of carbon, so we are going to say 2 multiply 8, and then the answer will be 24. Then save this number for later. The second step is writing the real number, and we call this step التكافؤ or valence electrons, which is the real number of valence electrons here. So we are going to multiply 4 atoms of hydrogen multiply 1, because hydrogen has actually one electron in the one valence electron. And then we will add 2 carbon atoms multiply 4 valence electrons, because carbon has 4 valence electrons and actually H has 1 valence electron. And then we'll save it for later as well. Now you might ask, why do we multiply the number of H atoms by 2 and the number of any atom by 8? Well, actually because the first step is الرقم النظري, which is the theoretical, the thing that we imagine. It's not real, but we want it to be real, what we love to see in an atom. Because H actually has 1 valence electron, and it needs another another electron to be perfect stable. And the same thing for any atom. Any atom in the world wants to have 8 valence electrons. The third and fourth step are bonds and non-participant, الروابط وغير المشاركة. To have the value of bonds, we are going to subtract نطرح 24 من 12 and we'll get 12. And then to get the non-participant number, we are going to subtract 12 from 12 and then we'll have 0. Now the fifth and the sixth step are the number of bonds, عدد الروابط, and number of those paired electrons. And number 5 and 6, they are the ones who will help us in drawing the molecule. So to get them, we are going to divide by 2 for bonds and divide by 2 by non-participant. Now number of bonds will be 6 and the number of paired electrons will be 0. Let's try to draw it now. The information are ready for us. We are going to draw 2 C's and then we are going to try to finish the 6 bonds. And we have the first bond for the first H and the second bond for the second H, the third bond for the third H, and the fourth bond for the fourth H. Now we have 2 bonds still until we reach 6, so we are going to put it between the C and the C, because carbon can do about 4 bonds. Take HCN as another example. First we are going to write the theoretical number, which is, we have H here, 1 atom of H multiplied by 2 valence electrons, and then we have 2 other atoms, not H, so we write 2 multiplied by 8, and then we'll have 18. We are going to save it for later. The second step is the valence electrons, or the real number. We are going to take the 1 hydrogen atom and multiply it by its actual valence electron number, which is 1, and then carbon, 1 atom, multiply 4, 1 multiply 4 valence electrons, plus N, 1 atom, multiply by 5, and then we'll get 10. Now we are going to save it for later as well. The third and fourth step, bonds and non-participant, which is when we subtract 8 from 10, we'll get 8, and then 10 from 8, we'll get 2. Now the fifth and the sixth step, which is when we divide by 2, divide by 2. Now we'll get 4 number of bonds, and we'll get 1 number of the paired electrons. Now to draw it, usually C is always the central atom because it has 4 bonds. We have 4 bonds that we need to finish and 1 valence electron. So we are going to see the 4 bonds first. 1 bond with the H. Now we have 3 bonds. Where are we going to put it? We are going to put it with the N, because N can make 3 bonds and C can do that as well. Now so we finished this step. What about this pair? Where are we going to put it? Now to know that, we need to count if the H is stable. No need to put it for it. So now H is stable, it have 2 electrons, that's good. Carbon 1, 2, 3, 4, 5, 6, 7, 8. Well, carbon is stable as well, that's good. What about N? N is 1, 2, 3, 4, 5, 6. It's not stable, it needs 2 electrons, which is 1 pair. So we are going to take this one and put it here beside the N. Now the molecule is good and the atoms are stable, all. What about if we have H3O plus? What are we going to do? We're going to do the same steps, but within 1 additional step. The first one is the theoretical number, which is we have 3 H atoms, so we are going to say 3 multiplied by 2 plus 1 other atom, 1 multiplied by 8, and then we'll have 14. The second step is the valence electrons, takafu, which is 3 atoms multiplied by 1, the real actual valence of electrons number, and then we'll say 1 multiplied by 6, which is 9. Now because we have 1 plus here, we are going to minus 1 from the here, and then you'll have 8. So if it is plus in the molecule, you have to subtract 1. If it is minus in the molecule, you need to add 1, or add the number which is in there. Now the third and the fourth bonds and then non-participant, we are going to subtract 14 multiplied by 8, and then 8 from 6 we'll have 2. Then the fifth and the sixth number of bonds and the number of the paired electrons. Divide by 2, divide by 2, we'll have 3 bonds and 1 pair that we are going to add to the drawing. O here is the central atom because it's the most electronegative atom in the molecule. So we are going to have 3 bonds here with H, H, and then H. So we finished the 5th step. The 6th step is to put it on O. We are going to put it on O because H is stable, H is stable, H is stable. كلهم مستقرين except of O. Now the molecule is good. But there's one last step, which is this. We need to add the plus because it's in the actual question. So after finishing the whole drawing, you need to put this brackets, then the charge. This is a new idea. If we took SO3 and we want to draw it, the first step is writing theoretical number. We have no H here, but we have S and 3 O's, so we are going to say 4 multiplied by 8, and then now the second step is the real number. S can make we have 1 atom of S, and we will multiply it by its valence electron, 6, plus O, we have 3 atoms O, multiply by 6 as well. The answer will be 24. Now the third and the fourth step, bonds and non-participant. 32 minus 24, we'll have 8, and then 24 minus 8, we have 16. Now the fifth and the sixth step, which is the number of bonds and the number of the paired electrons, we will divide by 2, 4, and then 8. Now let's draw it. We have SO3. S is the central atom because it's alone and can make a lot of bonds. We'll say 1, 2, and then we'll have 3. We'll write O, O, O. But we don't have 3 bonds. We found يعني طلع معنا 4 bonds. So we can do something called resonance. Okay, that we can put the 4th bond here, or here, or here. الرنين. But first, let's خلينا نقول إنه حطيناها هون, and let's put the paired electrons here. So we have 3 choices. But first, let's put the paired electrons. We have 8. Now 1, 2, 3. If we count it, 1, 2, 3, 4, 5, 6, 7, 8. Now this is stable. Let's continue. We have 5 left. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Now this atom is stable as well. We still have 1, 2, 3, 4, 5, 6. We have 2 pair of electrons left that we will put it on the O. 1, 2. Now let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8. Now this atom is stable as well. This is stable. This is stable. This is stable. Now let's see if S is stable here. 1, 2, 3, 4, 5, 6, 7, 8. No, yeah. Now the new thing here is we can write it instead of writing it here or here or here, the bond, instead of writing the bond here or here or here, we are going to write it in this way: S, then O, 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 with their paired electrons, and then we are going to put dots as if it is resonance.